So here we go. What is a vector? Okay, a vector is something that has a magnitude and a direction. Okay, I'll give you some examples of what is not a vector, like temperature is not a vector. Or salinity. So any concentration is not a vector. You just have value. Okay, but horizontal velocity is a vector in the ocean because it's a horizontal current that flows from A to B, that flows into a certain direction and moves object into a certain direction. Okay, and here's one example. A vector has a magnitude and a direction. You know, and if you draw an arrow, the red arrow here, it has a certain direction. Okay, you can see it points to the northeast. Okay, and it has a direction which can be expressed by this angle alpha in this direction. Okay? Vector can be expressed by its components u and v in this example, and you can plot the arrow if you know what the value of u is and what the value of v is. And these are components of the vector velocity, okay? And they should not be confused with speed. The components can be positive or negative. The u is aligned with the x direction and pointing to the east, and the v component is aligned with the north direction, with the y direction pointing to the north. Okay? So, you can always calculate the speed from the components. This is simply Pythagoras, and you just need to work out the square root of the sum of the squares of the components. It's written here, a little formula on the left side. Okay? On the other hand, if you know the direction and the speed, you can reconstruct, you can work out the components. Okay? So that is the basis. Okay? This is the basis. Okay, so how are directions defined? Okay, so that's the next step. So how do you define directions? Okay, I'll go over to the next slide, please. Okay, here, this is the definition for currents in the ocean, flow directions. Okay, so they are defined on the basis of radians, essentially. So you are looking at this compass here, and the radians vary from 0 to 2 pi, or you can express it in degrees. So you start with 0 means it's a flow that goes to the north, like shown here with this arrow. If you 0 direction, if you throw an object into the water, the object would drift to the north. Okay? It's called northward. Towards the north. Eastward is 90 degrees. Okay? Southward is 180 degrees and westward is 270. Okay, this is how you can define directions, okay, of flows in the ocean. It's totally different for winds, atmospheric winds. Horizontal winds are defined in a different way, and this is just shown here on the next slide. Okay, wind directions are defined the other way around. Where does the wind come from? So usually 0 refers to wind that comes from the north. 90 degrees refers to winds that come from the east, and the wording is also different. Easterly means wind coming from the east. Southerly means winds coming from the south, referring to 180 degrees. So you have to be a little bit careful. So that's just the traditional definition of directions, and it's different between currents in the ocean and winds in the atmosphere. Okay, for historical. All right. Okay. There is a little bit of problem with directions because you can see that at 0 you have a jump between 360 and 0, and that can give a little bit problems. Okay, and we're coming to that.